Welcome, network architects and engineers. Today, we are exploring NVIDIA Air, the ultimate platform for building data center digital twins. We will learn how to simulate complex AI network environments and identify catastrophic issues before they ever touch your physical hardware. Let's get started. Let's begin with the what. NVIDIA Air is a powerful, cloud-hosted platform that allows you to simulate entire data center networks for free. The basics are straightforward. It runs the exact same control plane software like Cumulus Linux and SONIC that runs on your physical NVIDIA Spectrum switches. It also runs NVIDIA NetQ for telemetry. Why is this critical? Because buying physical hardware just to build a test lab is incredibly expensive and slow. AI data centers scale to thousands of nodes. You cannot replicate that in a closet. How does it work? You log in via your browser and instantly provision infrastructure. For our deep dive, it's vital to understand that Air simulates the end hosts as well. This means you can run an Ubuntu server VM inside the simulation, install Ansible on it, and test your exact production scripts against a fully simulated leaf-spine fabric. Take a look at this flowchart. From your web browser, you access the NVIDIA Air Cloud. Inside, you can deploy a mix of virtual Cumulus or Sonic switches alongside virtual x86 servers. Notice how the switches interact seamlessly with the servers, while simultaneously streaming live telemetry data to the virtual NetQ instance, just as they would in the physical world. Slide 2 introduces a concept you must master: the digital twin. What is it? A digital twin is a perfect one-to-one logical replica of your physical data center. The basics involve mirroring your exact topology, OS versions, and configurations. Why do we build them? To eliminate fear. Making a change on a live AI cluster can halt millions of dollars of GPU compute if you make a mistake. A digital twin decreases your deployment time and prevents downtime because you test everything first. How? Because NVIDIA Air runs the exact same Cumulus or Sonic binaries as the hardware. Now for the deep dive distinction: Air simulates the control plane, not the data plane. It will prove your BGP peering and EVE-PNVXLAN tunnels form correctly and your ACLs work. It won't test 400 gigabit line rate throughput, but it guarantees your logical design is 100% flawless before you buy a single cable. This diagram illustrates the one-to-one mapping between your physical AI data center and the NVIDIA Air digital twin. Once mapped, the digital twin becomes your sandbox. You use it to validate BGP and EVE-PN protocols, test your security access control lists, and safely execute your Ansible automation scripts. How do we actually build these environments? Slide 3 covers topology creation. While Air has a great drag-and-drop UI, defining infrastructure as code is what professionals do. The basics are that Air accepts JSON or DOT files to build the network. Why do we prefer JSON? Because JSON offers superior syntax validation and scales easily when you are generating fabrics with hundreds of nodes. How do you do it? In your JSON file, you define nodes specifying the OS, like Cumulus or Sonic, and allocating memory. Then you define links, telling Air exactly which port on Leaf 1 connects to Spine 1. Look at the sample code. It's a simple key-value pair assigning 4 gigs of RAM to a Sonic Leaf. The deep dive trick here is embedding a NetQ node directly in your JSON. By doing this, Air automatically wires your simulated switches to the NetQ server, giving you instant streaming telemetry the second the lab boots. Here we dissect the topology JSON file structure. The file branches into nodes and links. The nodes define the hardware profiles, OS and RAM for your switches, servers, and NetQ appliance. The links define the physical port-to-port wiring. Once uploaded, the NVIDIA Air engine parses this code and renders your fully functional virtual lab. Slide 4 addresses a very common scenario. What if you already have a physical data center and want to create a twin of it? You don't have to manually type out a massive JSON file. You can clone production. The basics involve extracting the state of your physical network. Why? Imagine you have a bizarre routing loop in production. You want to safely replicate it and test fixes without making things worse. How do you do this? You run the standard CL support diagnostic command on your physical Cumulus switches. Our deep dive is where the magic happens. NVIDIA provides open-source Python parser scripts. You feed your CL support files into the script, and it analyzes all the LLP neighbor tables. It then automatically generates a perfect topology DOT or JSON file. You upload that to Air, and boom, you have an exact logical clone of your physical data center. This sequence diagram shows the cloning process. You pull the CL support data from your physical switch. The Python script parses the LLP neighbor tables to understand the physical cabling. It outputs a topology.json file, which is fed into NVIDIA Air, instantly spinning up a 1-to-1 virtual clone of your environment. Now we integrate Air into the modern workflow, NetDevOps and CI/CD pipelines. What does this mean? It means we treat our network like software developers treat code. The basics. Engineers use Ansible and the NVIDIA object model to define switch configurations. Why do we do this? Because typing CLI commands across 500 switches in an AI factory guarantees human error. Automation is mandatory, but pushing untested automation is dangerous. How do we stay safe? When an engineer commits code to GitLab, a pipeline triggers. It points Ansible at the NVIDIA Air digital twin and deploys the config there first. For the deep dive, Air isn't just a passive target. Once the code is pushed to Air, we run automated netqueue checks inside the simulation like netcheck BHP to mathematically prove the network is healthy. Only if those tests pass in Air will the pipeline deploy the code to production. Follow the NetDevOps pipeline here. An engineer makes a GitLab commit. The Ansible playbook deploys the changes directly to the NVIDIA Air digital twin. We then hit the critical netqueue validation gate. If the simulation fails, the deployment halts and alerts the engineer. If it passes, the exact same, proven playbook is deployed to the physical fabric. Let's look at a real-time, high-stakes use case. You are an engineer managing an AI cloud provider's DGX superpod. You need to provision a new multi-tenant VRF using EVPN symmetric routing. The problem, BGP route targets are complex. A single typo in your import or export policy could cause a routing black hole, instantly halting active GPU training jobs. You cannot risk doing this live. The solution is NVIDIA Air. You spin up your digital twin. You execute your proposed NVIDIA configuration against the simulated switches. The outcome, the netqueue instance running inside your Air simulation immediately throws an alert, flagging an asymmetric routing anomaly. You caught the bug. You go back, fix the typo in your Ansible Jinja 2 template, and rerun the simulation. It passes perfectly. You then deploy to production with absolute confidence and zero downtime. That is the power of a digital twin. This sequence perfectly illustrates the incident prevention workflow. The engineer pushes the proposed EVPN config to the Air twin. The virtual netqueue analyzes the state and alerts the engineer of a routing loop. The engineer fixes the typo locally, pushes the corrected code back to Air, and receives a pass from netqueue. Finally, they safely deploy the validated code to the live production network. We have reached our final slide. To summarize, NVIDIA Air is the ultimate risk mitigation platform for your AI data center. It gives you the power to simulate Cumulus Linux, Sonic, and netqueue at scale, using highly customizable JSON topologies. By validating your configurations in a digital twin, you prevent catastrophic downtime and accelerate your team's transition to modern NetDevOps. Remember, never test in production. Always integrate Air into your CI/CD pipelines so that every Ansible and NVIDIA command is proven safe by virtual netqueue health checks before it ever touches your physical hardware. Thank you for joining this deep dive. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. See you next time. This final mind map summarizes our journey. NVIDIA Air sits at the center, branching into simulation capabilities for your OS and telemetry, topology creation using JSON or CL support cloning, and vital use cases like validating routing, testing security, and empowering NetDevOps CI/CD pipelines. Keep these pillars in mind as you design your next AI fabric.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice papers paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now, the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.